everyone. My name is Moshe Zioni, and I'm here to talk about application security at scale. How do we do that, and what is contextual application security? Bringing up a presentation. By the way, excuse me if something is a bit quirky. This is the first time I'm doing OWASP over virtual, so this is pretty exciting for me as well. So thank you for joining. As I said, we are talking today about normalizing AppSec issues for contextual risk-based prioritization and enterprise scale. And this very long, I would admit very long headline is all supposed to say that what we have today as an AppSec issues, we don't really do that along the lines of context. And I'm trying to prove the point throughout the presentation. So my name is Moshe Zioni. I've been around for about 20 plus years in the InfoSec communities, especially in Israel and the US, in different positions and different passions, but all together security research, of course, this is the sole purpose for our being. Mainly considered myself as a pen tester and bounty hunter, and for the past 9 years, I've been devising more detection and prevention algorithms on different scales. On my last past life was in Akamai. I was director of threat research there, designing and controlling all of the cloud security solutions of Akamai. And now in Apiro, we are securing the life cycle of the development. And I will talk about that and we'll share some of our knowledge here by that. And of course, there's some reason for that is to share with the community and to see how can we change things that are still very slow and to try to bring it up to enterprise scale. So starting with why are we actually discussing that and why it's so important? So first of all, what we see in DevOps for the past few years, and maybe more than that actually, is that more and more automation is coming to place, and DevOps plays a key role into how fast can we release our applications nowadays. Traditional security says that it's very manual, very process heavy, and by that it really doesn't combobulate with the DevOps philosophy. And we always try in the community to bridge those gaps together. And by that, we also look at it as a more modern approach versus traditional approach. The current approach is that we see more and more on the arena of application security lifecycle is that we see more and more secure design, if it's more of a threat modeling standards and the way we are doing secure code practices. Of course, all of that comes together to what kind of knowledge we have in the community and how do we exercise this knowledge, especially when we are looking at what verification mechanisms we have developed over the years and what are we as enterprises are using nowadays. So what we always see is that SCA, of course, taking place, composition of those software that we are using and packages to see what kind of dependencies, what are those dependencies, capabilities, vulnerabilities, licenses. If we look at a SaaS, TAST, and YAST application security testing, mostly what we see is, of course, many vulnerabilities being found, a load of vulnerabilities that we need to tackle by that. And this is the minimum. On top of that, we also starting to see test orchestration, which is very good. We see more and more orchestration on those arenas, and by that we see that try to work out an automatic workflows for correlating those vulnerabilities with the production systems. And finally, fuzzing, we also see continuous fuzzing going as a trend, and we look for more and more things to do, especially true while we are considering agile development. While we thought of traditional security as non-agile and non-agile ready, what we are trying to do with current security, and when I say we, it's global we in terms of community all around the globe, is we try to keep up with the agile development lifecycle trend and by the velocity that it demands. By that, to be honest, all of those systems brings up together a new kind of category, and a new difficulty for us as security practitioners is to have all of those items on unders and features, and we never try to hinder development. We try to make development fast, and that said secure. And this is some kind of a very tight balance that we try to to act together, but with not much help. And what I'm trying to say here is that without the context, the correct context for those automatic systems, we won't be able to come along all of this path that we see that we either block, and by that we are not releasing on time, or we are accepting the risk for any reason that we have, and by that just releasing and knowing that there are risks to be taken because we don't want to hinder the release cycle velocity. And one more challenge I will discuss before I'm going into the detail of how are we going to tackle that and what is the proposed approach here. Is that we also know that the number of security architects is still low in regards to how many developers each architect should support. And of course, part of that is also really hard for those architects to really have this kind of say within their platforms and enterprises, is that first of all, the lack of visibility. They don't know, they can't map all the time the continuous and really rapid development that developers right now have on their hands, especially when considering cloud services right now with infrastructure code and stuff like that. It really brings a lot of visibility issues into play. Second, the cost of remediation is still high, which part of those decisions for the SDLC is very late into the SDLC lifecycle. We mostly see those kind of decisions taking place on the release side, so it's very far away, far right, what is said with the DevSecOps communities, really far right on the scale of where remediation should be taking place, while trying to make a shift left, making this kind of remediation decisions as early as we can in this design and development of those kind of features and code. And lastly, slow time to market. We try to do everything automatic and not manual. All of those kind of things and the things that you see on the screen are really putting the architect in a very tight position. On top of what all of been said right now, we shouldn't forget that the issues themselves are just accumulating, and those kind of issues can come from either automatic or manual tests that we are doing along those SDLCs that we have. On top of that, if we just need a quick reminder, our supply chain attacks that we see more and more over the past 2 years is not going away anywhere. And this is a new, I won't say actually not a new type of attack, but something that has been just trending with attackers for the past few years. And more we are more conscious about those supply chain attacks nowadays. So there are three things that we're going to discuss. One is why contextual data is very important, what we are bringing, what we are considering context that's really important for us to keep. Second, on the normalization, a very short maybe introduction to what is normalization and how to do that within your systems to be aware of this normalization need. And thirdly, how do we do it at scale? If we're talking enterprise scale, we are talking tens of thousands, maybe repositories. We've met with enterprises that have new repository every day, or even more than that. So at scale, it's very important for us as well. So we are going to touch upon that, and we are going to finalize with the takeaways for you. So let's start with contextual. What we are trying to do with context is that we are trying to bring along this kind of idea, which we know that a Jira ticket can be, for example, this is starting with design. So someone needs a feature to collect something. So John goes ahead and do a code change according to Jira ticket and start to tweak the API logic. Then we can see a cloud change because we need to expose this kind of API on the API gateway that we have. So someone is making sure that the code that is configuring the API gateway is being updated as well, maybe the same way that John is doing that, maybe on the same computer, or maybe even on the same breath if it's very easy. On top of that, all of that really affects the PII field that is being added because of this need of the new data. And if it's not enough, he should also apply this kind of application on a daily basis and then deploy it to the cloud. So all of those things are new events, and by that you also can think of what kind of semantic context we can bring to the table. Specifically, if someone commented on the push request from John, And more than that, if we actually look at the API that we have been exposed, maybe the API is not considering authorization at all. And lastly, what we are seeing here are very critical pieces of information that, first of all, are not strung together, meaning they are not interconnected some way to bring that all into one story. And second, the important pieces of information, which is a new change, which the API configuration is not including something or including something or touching upon a specific mechanism that is important for us. And by that, this context brings us the idea of why it's important, why it's more important than others, why it's a material change, why it's something that is worth our time. Remember that the accumulating issues will never stop, and we'll need to either shoot them away very fast, or we are going to tackle them with some context, and by that have this priority also in place. And no one currently is looking at that. So we don't have the power and the community to do that. So that's part of what we are trying to do. And if we're looking at a sequential model that the DevSecOps have, we also see those kind of caveats all the time. What is going on in the security design, and what kind of solutions you're going to use, and all of that. If we look at the infinity aid that we see on the DevSecOps cycle, we understand that this cycle is not really a cycle more than something that is being done all together as an agile model alongside each other. So the correct way to see that is the continuous model that we never stop doing planning, we never stop doing creating, and it's not something that we are going to block by each other. And that's the way, by the way, that developers are working on it. Maybe they are working on one feature each, but it's because of how Git works and how Git operations are working right now. It enables them to work very, very fast on different branches without considering each other, and by that, it's still they have the ability to release the stuff very, very fast if we are not considering security for a second. All of that comes together to one point, that the inventory itself that we have is incomplete, and we need to have this kind of information together to have this kind of context. Now, finally, when we look at all what we said, is the thing that we are trying to wrangle together in order to have context is the code itself. This is pretty straightforward to understand. We have a Git repository. We have the history maybe of the Git repository, or repositories plural, I should say. Contributors, which contributors have contributed what to where, and why it's important. Maybe it's a new developer. It's a different risk for a new developer. If it's a developer that already touched upon a mechanism of authentication, and next time he's going to touch upon authentication mechanism, he will be less risky statistically by someone that never touched upon authentication mechanism, and it's his first day on the job maybe. So the contributor context is very, very important. It was one of the biggest things that we are looking at when we are looking at context. Lastly, this kind of semantic discussion, metadata for tickets, is very important as well. So it gives us a lot of context information about what happened and the journey that the feature have gone through from design to code to the cloud itself. And all of this is being funneled into what we call material changes again. So what is important in the change? Not just a change. A line of code that's been changed is nothing important in, let's say, in the color of the login page is not something of a material change. In terms of perspective of the code itself. It's something that is mostly not considering anyone else in terms of material change for security. And this is why it's very important for us to tackle the security elements and not every kind of code in the same time or in the same level. So all of that, after we have material changes and we understand the concept of them, we can really point out what are the risky material changes. And when we have all of this together, we can really point out why it's the high risk from that lot of the risky material changes and decide on what to do. And then we can wisely distribute our resources over that, and to have a wise workflow for each one. One can demand the penetration testing, while other should have a code review for a second, for example. So all this again is something that we're taking into account. Now, what we said so far maybe made sense, but let's go for a use case that we used. So just a year ago, there was a PHP core attempt on backdooring the PHP core code. And by that, we took the code, we took all of the history of the commits, and especially the semantic ideas, the metadata that they have on the code journey that they took, if the PRs and commits that it have, and we found it through what we have with the models that we have for anomaly detection. Now you can think of multiple anomaly detection items, but in general, those items we parsed it, and then we looked in these anomalies, and then we have scored those anomalies. Altogether, when we only looked at the critical scores, we came up with one single commit, which is evidently was the commit that was the backdoor itself, because the way the developer was behaving before that wasn't fitting to the way the behavior that the developer have been allegedly committed this malicious commit. Normalization, I'm going fast over that because there is not much to say, but because it's really important to understand the data. But 3 takeaways from the normalization: the data itself, especially from different tools, won't have a normalized idea of what is the distribution like, and shouldn't consider the scoring to be consistent. So making coherency over this kind of data feeds is very, very important. And keep in mind that sometimes even the same data feed would not have a coherent scoring because it won't have considering the context of the environment that it lives in. So it's really important for us to normalize the data. How to normalize data, this is maybe an effort for a different slide deck next time. Lastly, on enterprise scale, we need to consider 4 things. We want you to consider 4 things. One is the general purposeness of the scale itself. We can build something very specific for a specific product or project or repo, and we need to consider the main idea of how workflows are going on different life cycles, and by that we need to think ahead of what is worth our time in terms of automation to fit the general purpose of life cycle of developers. And we should consider this as those life cycles are agile. We shouldn't be less agile than developers themselves. Cloud-based is something that we are taking into heart because this gives us a lot of freedom about how to handle those kind of cases, especially when we are talking about resources that are demanding for this kind of crunching over security. And lastly, performance optimization is really important to think about what deserves what kind of attention. Maybe something should be highlighted as the code itself is very important. If we can put out the material changes themselves, they deserve a better treatment than those that are not. Altogether, this brings us to the same idea. The takeaways themselves that the agile development cycle should be the same as the agile security cycle. The context is king. We should consider context all the time. Without normalization of the data, we won't be able to actually coherently look at the data sets and decide of what action should we take. And lastly, the optimization and consistency of automation is super important for us for the long run altogether. That's it. I think I'm on time.